Every sunrise brings with it a promise, you know? It is the promise of light, of warmth, and of energy. For centuries, humanity has sought to harness this energy to power its dreams and ambitions. We have moved from fire to steam, from coal to oil, and now we stand at the precipice of a new era. This is the age of clean energy, powered by the sun and by the wind. We are building a future where our power is as clean and boundless as the sky above. The scale of this transformation is truly breathtaking. Across the globe, we are witnessing the largest and fastest energy transition in human history. Millions of solar panels are being installed and thousands of wind turbines are rising to meet the sky. Yet, they come with a fundamental challenge. The sun does not always shine and the wind does not always blow. This intermittency is the Achilles heel of renewable power, creating a critical gap between when energy is produced and when it is needed most. The revolution on our roads is already well underway. Millions of electric vehicles now glide silently through our cities and across our highways. This shift is a monumental step forward in our fight against climate change. Each of these vehicles is powered by a sophisticated, high-capacity lithium-ion battery. These batteries are marvels of modern engineering, capable of storing vast amounts of energy in a compact and relatively lightweight package. This incredible growth, however, presents a new and looming challenge. The global fleet of electric vehicles is projected to grow exponentially in the coming years. We are talking about hundreds of millions of cars, trucks, buses. The question then becomes, what happens to these batteries when their first life on the road is over? According to Bloomberg NEF, by 2030 we could have over 200 gigawatt hours of retired EV batteries coming offline each year. The solution begins with a simple but powerful idea, a second life. And instead of being discarded or immediately recycled, these batteries can be repurposed and they can be given a second life in a less demanding role, stationary energy storage. This is the hopeful thesis at the core of our film. By repurposing these batteries, we can create a circular economy, extending the life of valuable materials, dramatically reducing the environmental footprint of electric vehicles and the power grid. To truly understand the scale and impact of this revolution, we will take you on a global tour. Our story beats will be driven by real-world data and compelling case studies from the front lines of innovation. To understand the Second Life revolution, we must first look deep inside the technology that makes it all possible. This is the lithium-ion battery. Inside every EV battery pack are hundreds, sometimes thousands of individual cells. The magic happens when the battery is charged or discharged. During charging, electrical energy from the grid pushes lithium ions from the cathode through the electrolyte and separator to the anode. When you drive the car, the process reverses. From the very first time it is charged, a slow, irreversible process of degradation begins. Every time lithium ions travel back and forth between the anode and cathode, tiny side reactions occur, gradually consuming active lithium and electrolyte. An EV battery will typically lose about 2% of its capacity per year. The generally accepted threshold for retiring a battery from an EV is when its SOH drops below 80%. However, a battery with 70% SOH is far from being junk. Once the healthy battery modules have been tested and graded, the next step is to repackage them into a new form factor. The art of repackaging involves transforming these automotive components into uniform, modular building blocks for a new life. These blocks can be stacked and connected like Lego bricks. You could use a single block to power a home or combine hundreds inside a shipping container to create a multi-megawatt hour system for a utility or large factory. If the battery cells are the muscle of a storage system, then the battery management system, or BMS, is its brain and nervous system. It constantly monitors key parameters for each cell, including voltage, temperature, and current flow. Advanced Second Life BMSs use sophisticated algorithms that understand the unique characteristics of aged cells. They can adapt their control strategies to get the most out of the degraded battery, managing its quirks to ensure a long, reliable second life. Among the most promising contenders to augment the dominance of lithium-ion is a technology built on a remarkably common and inexpensive material, sodium. Sodium is over 1,000 times more abundant in Earth's crust and seawater than lithium. This opens the door to a battery chemistry built almost entirely from cheap, abundant, and sustainable materials. The anode can be made from hard carbon produced from biomass waste like coconut shells or wood rather than highly processed graphite. What if the very fabric of our built environment could store energy? This is the mind-bending concept behind structural batteries. The idea is to develop a rechargeable cement-based battery integrated directly into foundations, walls, and structures of buildings. When you consider the sheer volume of concrete used in a building's foundation or highway, the total amount of energy that could be stored is staggering. It could turn our cities into massive distributed energy storage devices. To make all these physical components work together in perfect harmony, we need a powerful intelligence, a digital maestro, to conduct this complex orchestra of energy. This is the role of artificial intelligence. AI-powered forecasting algorithms are becoming incredibly accurate at predicting demand and generation. By continuously analyzing historical data and live inputs, these systems can create highly detailed forecasts that allow grid operators to prepare for what lies ahead. Once an AI system has a clear forecast of supply and demand, its next task is optimization. The AI must know the capability of every asset and dispatch it perfectly, solving a complex, multivariable equation in real time. Beyond forecasting and optimization, AI acts as a vigilant doctor for the battery itself. It learns the unique normal signature of each module and watches for tiny deviations, early warning signs long before critical failure. Our global tour begins in Germany, the industrial heart of Europe. Here, the approach to second life batteries is defined by engineering excellence, industrial applications, and robust policy frameworks promoting the circular economy. German companies are not just viewing second life batteries as environmental obligations, but as strategic assets. The German government has enacted laws emphasizing producer responsibility, creating powerful incentives for second life solutions. From Germany, our journey takes us to China, the undisputed heavyweight champion of the battery world. Here, the story is one of mind-boggling scale, breathtaking speed, and vertical integration. One of the most iconic projects is China Tower Corporation, which has stopped purchasing lead-acid batteries and now uses exclusively Second Life lithium-ion batteries for its vast network of over 2 million towers. Our next stop takes us to Indonesia, the world's largest producer of nickel. The country's story is an ambitious national strategy to build a complete domestic, closed-loop battery industry from mine to recycling. They are exploring how repurposed batteries can bring stable electricity to thousands of islands that still rely on expensive diesel generators, creating a perfect domestic market for Second Life products. Our final case study brings us to the United States, where the Second Life story is being written by nimble startups, forward-thinking utilities, and empowered communities using technology to solve local problems. In disadvantaged areas at risk of power shutoffs, non-profits and local governments partner with Second Life providers to build local energy resilience, creating hubs that provide safe, powered locations during emergencies. For any new technology to achieve widespread adoption, it must make economic sense. The fundamental economic advantage is straightforward. The most expensive component, the battery cell itself, can be acquired at a fraction of its original cost. A lower price is only attractive if the product performs reliably. Through rigorous testing and grading, system integrators can provide clear specifications for their Second Life products, guaranteeing capacity and modeling expected degradation. Creating a smooth, efficient pipeline to collect millions of used batteries and transport them to processing facilities is a monumental task. This reverse logistics network is being built from the ground up. As the Second Life battery market matures, innovative business models are emerging. From automotive OEMs creating energy divisions to startups offering energy as a service, diverse players are finding unique niches. In Amsterdam, the Johan Cruyff Arena is powered by a 3 megawatt energy storage system made from the equivalent of 148 Nissan Leaf batteries. This system helps power the stadium during events and provides grid stabilization services. In the United States, companies are deploying Second Life systems at utility scale. In California, projects now participate in wholesale energy markets, charging when electricity is cheap and discharging when expensive. Perhaps the most inspiring examples bring power to those who need it most. In developing countries and remote communities, small microgrids with Second Life batteries provide clean, reliable electricity for the first time. These projects do more than keep the lights on. They foster shared purpose and local control, create local jobs, and can generate revenue by selling excess energy back to utilities. The life cycle of an EV battery represents a powerful new model for circular economy. It transforms a potential waste problem into significant economic and environmental solutions, creating value at every step. For the automotive industry, it creates new revenue streams. For the energy sector, it provides affordable storage for renewables. For businesses, it offers lower costs and resilience. For communities, it provides energy independence. Moving from inspiration to action requires concerted, collaborative effort from all sectors. Policymakers must create supportive regulatory environments. Industry must design for circularity. Investors must recognize Second Life storage as bankable assets. Throughout our exploration, we have found that the most powerful element is the human one. This revolution is driven by human ingenuity, passion, and shared desire to build a better future. We stand at a remarkable moment in history. The story of the Second Life battery is a powerful metaphor for the transition we must all make. It is about a second chance for a battery and for our planet. We are stepping into the circular age, defined not by consumption and disposal, but by reuse, regeneration, and resilience. The storage revolution is here, powered by old batteries, new ideas, and the enduring power of human ingenuity.